Well, my name is Peter Schöffel, and already now I'm in trouble because I'm working for Glashütte Lamberts in Waldsassen, Germany. When preparing this presentation in advance, I was talking to Mrs. Christina, who said, as I'm from a commercial company, from a producing company, I should not be allowed to use this as advertisement platform. So I try to stick on this request as good as I can. If not, just ignore what I said. So today I will talk about something invisible, mostly invisible, which is glass. I will talk about something, again, invisible, mostly invisible, which is light. In this special case, UV rays, so the really invisible light. So first, a quick glimpse into the factory where I'm working and where this glass is made. The topic is mouth-blown UV filtering glass. Why mouth-blown? Because it's possible with mouth-blown glass. If we would be a big industrial producing company which is producing float glass, then it would be not possible to make testings, because we produce in small pots, relatively small pots, 500 kilos, and so there we can do a different test every day. If you have a big industrial production, you have 40 tons of glass or something per one day, and you don't waste 40 tons for one test, and you have to make 30, 40, 50 tests. So a little view into how the glass is made. It's a very traditional technique. It's going back to year 600, more or less. So since that time, the glass is made like this. We are blowing big balloons. These balloons will be opened. These are the cylinders. These big balloons will be opened. Afterwards, the cylinders, and the cylinders will be cut. And afterwards, they are flattened. Then it's a sheet of glass. Well, why UV protection? So we are here at a conference where we are talking about preservation of material, paper, textiles, metal, wood, glass, everything. And so UV rays, they are very bad to this material. So they are destroying this material. And so it's quite sensible to have something which protects this. So in the very end, if this would be used very consequently, you would be unemployed afterwards, so because there will be no further destroy of material. So, as I told, it's wood, paper, paintings. This is all very sensitive to UV ray. This is a glimpse to the spectrum of the light. So we are at the very left end where we are talking about the UV rays. So far, our solutions on the market to protect or to have this UV protection, this is films which you apply on glass, or it's coatings which are applied on glass. So the problem with this material are they are more or less organic, and they suffer from the UV ray themselves. So that means as soon as I apply it on the glass, as time goes by, the function of the UV filtering will go down step by step within years, 15 years, 20 years, 30 years. The advantage of these solutions, of course, is you can apply this inbuilt. So if you have a window, you can apply such a film if necessary, directly on the glass. You don't have to take the glass out of the frame. So these are certain advantages you have with this traditional material. If you use our glass, you of course have to remove the old glass from the frame and put in UV filtering glass. So when we, let's say, invented this UV filtering glass, the main idea was to use it in museums. So there where sensitive products, goods, art pieces are, and they have to protect it. But so far, we did no order so far in this museums. It was all things which I will show now, which are very surprising focus. So this was Altenberg Cathedral. It's in the west of Germany. So there you see this quite yellow face. This was somehow reconstructed with araldite, and this araldite went yellow as time went by. And so this was a quite disadvantage, and so they are using the UV filtering glass to protect the araldite from getting yellow. So it was something complete. We could not imagine this, so that this could happen. So something technical. So if you are common with such lines, not lines, with this schedules, tables, then you see that there is at 400 nanometer a very sharp cut. So if you show it in lines, you see this very steep line. This shows that you have, you have visible light here, and on the left side of this line, there is no transmission of this rays, of this UV light. As steeper this line is, as better the quality of the UV filtering is. So another project which was done with UV filtering glass was in Wittenberg. It was the Lukas Cranach altar, which has to be protected from the UV rays because it was suffering quite a lot. And so the apsis was made with this UV filtering glass so that there will be no further damages on this altar. So by the way, Wittenberg is this town where Martin Luther were praying. So another project is in southern Germany, which is Metten Abbey. So it's also because of the interior, there is an organ, a very old organ, which has to be preserved. And so in a very, the window is even not visible, but there goes the light directly to the organ. And so this window was made to preserve the organ. And coming back to araldite. This was at least the first work which was done with UV glass. So the east window of this famous York Minster Cathedral was restored. And they restored it as it is quite usual with araldite. And during the restoration, there came up the discussion what will be in 20, 30, 50 years, because people know that araldite is aging, and what can we do? Shall we restore it again in 50 years? Or shall we find a solution to do this not? And so somehow we came into this project, and it was decided to use a UV filtering glass as protection glazing. So it's common to use at such stained glass windows to have protection glazings. Usually they are made from normal glass, but in this object it was decided to use the UV filtering glass, because this UV filtering glass will protect the araldite from the UV damages, and so it probably is necessary to restore this cathedral in 100 or 120 or I don't know 130 years or something. So the durability is much longer. It was for us it was really a quite interesting aspect, as we thought museums would be our main focus, but so far was no museum. So this is another view from the top. And a complete view on the nice window. Then when talking about UV filtering, so we saw this spectrum of light where UV was on the left side. So then there is infrared on the other side. So infrared filtering glass is available since not centuries, but definitely since decades. In every car, meanwhile, is infrared filtering glass. So this is not a big miracle. So we can produce it as well. But what we are about is to try this. This is hopefully the future, so it's not so easy at the moment, but this could be an interesting thing if the function of UV filtering and infrared filtering is in one glass together. So I remember a situation when I was in Vienna in Schloss Schönbrunn. I was there as tourist, and I went through this hundreds of rooms, and some of them were protected with very heavy curtain, because inside were also very valuable things, silk wallpapers and paintings and so on. And so that no UV ray goes into these rooms, they used curtains. But curtains darken the room, so you need light. So this was at times where the regular bulb light was quite common, or halogen. So this meant the room is heated up because of this light. And furthermore, they need air conditioning to bring back this temperature, bring down this temperature. And so my opinion would, if there would be a glass like this, then you had all functions in one. You can go in this room under a regular normal situation, under a daylight situation. You have no heating from the sun in this room, and you can enjoy all these art pieces under normal circumstances. So, but it's quite difficult, so we are about to do this, and yeah, I think that's it.
We still have a little bit time. If there is any questions to Peter.
It was very interesting, thank you. I'm wondering how you modify the glass. I don't want an exact receipt, but main idea.
What do you mean with modify?
How you made the glass your way.
So to be honest, it's a secret.
Yeah, I know. But the main idea.
No, It was an idea from our boss to develop this glass because he knew about these films and coatings, and he thought probably there is a solution to have this in glass. And so then development started, and after the very first shots, so 3-4 tests, it worked. And then we went forward and it stopped working. And we did not know why. So, and then this 50 further tests became necessary. So at least it's a thing of the ingredients in the glass. So if you are producing glass, it's sand, lime, and soda. And if you would like to have color glass, then you add cobalt, iron, copper, whatever to have color glass. If you would like to have UV filtering glass, you have to add, I read in English, something with cadmium. So but it's not the original cadmium. It's I don't have the word. It's a connection with something else, and so it's not that bad cadmium. And so if this goes into the glass, then this filtering effect is coming up slowly. So it's a very fragile process. So it has to be treated, quite seriously. But more or less, to answer your question, it's the ingredients.
So,
I ask in loud voice.
all right.
Yeah.
Are you making also such a special glasses like optical white glass and anti-Newton glass?
What was the second?
Optical white.
Optical white.
And anti-Newton.
Why?
Yeah, not really. So as we are producing traditional glasses, we have we have a clear white in our program, but this is not a clear white where probably a photograph lens producer would understand clear white. So we still have a little of this iron, of this green tint in the glass. So it's not a real optic technical white. So for architectural use, it's definitely a clear white. So, but not for technical use.
Yes, I understand. But what is the best transparency of your glasses?
Yeah.
I know that the glasses with the transparency is 92%.
Yeah.
Is it true, or is in this area some changes? What is the best glass?
So
Transparency of the
So, sorry, I have to call my production manager. So, one basic item is that our glass, our regular glass, not this white glass, is comparable to industrial float glass. So when industrial float glass has a transparency of, I don't know, 92%, then we have more or less the same value. So probably the more clear one goes up to 95. But these are very technical aspects. I don't know, because in restoration business, this is not so important.
So there was another question there.
Oh, I'm Tiina Paavola from Finland. I have two questions. What is the biggest size of the window sheet you can make, and what are the expenses of this special glass? I mean, comparing to the normal window glass.
No, okay, because these are always the most interesting and most difficult questions. So the general size of a glass we are producing is 60 by 90 in color glass. As this UV filtering glass is a little bit more difficult, so we don't reach the sizes. So at the moment, we are about to develop, but at the moment, we say we are about a 50 by 60 centimeters maximum for UV filtering glass. And the second thing is the price. It always depends, of course, a little bit of the project. and it's very difficult always to talk in such a big audience about prices, but let's say roughly about 400 euros per square meter is a value you can keep in your mind.
Well, thank you.